Hi everybody. Today I will begin my presentation on a topic that is not only a fresh trend in the technology sector but also plays a hug important on ensuring the safety and performance of industry. Aviation is the detection and treatment of cracks in aircraft structure through machine learning technology. The risk of crack in aircraft structure not only threatens flight safety but also has a serious impact on maintenance and operating costs. This creates an urgent need for application of modern methods to detect and evaluate crack accurately and effectively. In my presentation, we will discuss an approach that uses machine learning to identify and in magnetic image, opening the door to solving this important challenge in aviation industry. Let's dive into how this technology can improve aircraft maintenance and safety process and how it can contribute the sustainable development of the aviation industry. Thank you for taking the time to participate in my presentation. Let's get started. My presentation consists of 6 parts. Safety is always primarily in aviation. Corrosion problem in the gap around both how can pose a serious threat to aircraft safety. This poses a great challenge in detecting and determining the exact location of cracks. This project focused on employing machine learning to accurately detect cracks in magnetic image. The goal to select an appropriate algorithm pre-process image, train the model using labeled datasets containing crack and subsequently test the model to evaluate its accuracy. Additionally, the project entails making necessary adjustments to enhance the model performance. This machine learning model has a potential to improve the testing procedure and ensure aircraft safety by early detection and precise localization of cracks in hard to reach areas. We will use a whole sensor array to scan the metal plate surface, then obtain from the field and group them to 50 times 7 times 87 image and is the corrosion. It is the my result. This corrosion and in the image we have a no corrosion. The dataset consists of 720 samples divided to 3 subsets: training set, test set, and validation set. The training set account of the majority with 4 and 35 and 32 samples, equivalent of 60% of the total number of samples. Remaining both the test set and validation set include 144 samples, accounting for 20% of the total number of samples for each set. Now we go to my model architecture. My model includes 2 convolutional layers and 2 fully connected layers. The first convolutional had a 32 channel kernel size of 3 and stripe of 2. This filter search for local feature in the sample. The second of convolutional layer has 64 channel kernel size of 3 and stripe of 2. This filter look for complex feature in the sample. Before giving output of convolution layer to the fully connected layer, we must flatten the output The fully connected layer is traditional backpropagation neural network layer. This class have 128 nodes corresponding to the number of classification class 2 cross-version or no cross-version. And we use the value activation in each hidden layer and short mark to classify in output layer. In this problem, we will use multi-class growth entropy with regularization as the load function to avoid overfitting. This is formula of multi-class growth entropy loads with regularization. The load function in this figure is a load function that gradually decrease with the number of epochs. This shows that model is learning and improving its performance over time. At epoch 0, the load function have a value of 0.69. This value quite high, showing that model is predicting very poorly. However, after changing for 100 epoch, the load function dropped to 0.68. This value is significantly lower than the init value, indicating that the model have learned to predict more accurately. And this figure shows the accuracy of training set, blue line, and validation set, orange line during training. We can see that model accurate increase during training process. Although the model has quite good accuracy when observing confusion matrix in this figure, we can see the sample in class 0, this is cross-version, are unwrongly predicted. And the last, we see the classification report of me. Precision of class 0 is 0, meaning there are no cases that are predicted to be class 0 correctly. Precision of class 1 is 0.71, which means that in case predicted to be class 1, about 71% of prediction are correct. Then we see the recall. Recall of class 0 is 0, meaning that there are no instances that actually belong to class 0 that are correctly predicted. Recall of class 1 is 1, which means that in case actually belong to class 1, the model predicted 100% correctly. Now we see F1 score. F1 score is the harmonic average between precision and recall, right? Helping to evaluate model performance. The F1 score of class 0 is 0 and class 1 is 0.83. The large difference between the F1 score of the two classes, so the model focus on classifying better on class 1 than on class 0. Now we go to my conclusion. During the classification process, our model achieved quite good result with class 1 classification, with a recall rate of 100% and precision of about 71%. However, the model could not correctly classify sample belonging to class 0, causing both precision to recall to reach result 0. This though a major improvement in the model's classification ability of this class. Although the accuracy rate is about 7 71%, which partly reflect the overall performance of the model. It cannot hide the large difference between the two classes. The lack of balance in classification can have negative consequences in practical application. To, im- to improve model performance, we propose several approaches such as enhancing data collection of class 0 using resampling or augmentation technique and adjusting model hyperparameter. Additionally, more complex model architecture or other techniques such as transfer learning can be considered to improve classification capability. In summary, although the current model strength in a class 1 classification, the last is my future plans. In my future, we have to improve the efficiency of the model and correct identify the conclusion location. The presentation is finally. Thank you for listening.